Hi, everybody. Thanks for coming out. So to start, a little bit about me. I am Devon Stewart. I have been doing this for a bit. You may know me from Guardrail fame if you're from the Scala community. I've been writing a compiler for about 5 years, 6 years now. Guardrail.dev, it's pretty good. I'd suggest using it. It's a lot of fun. But today I'm going to be talking about something else, which is a mistake that we've all made. Hand wave you a little bit. Maybe you're smarter than me, but I've made it certainly a number of times, where I start writing a service, or I start writing code for, let's say, a small company. I'll start writing some sort of code, and then it just starts getting out of hand. So if we just take a little walk through what that looks like. If we start a company, we're going to write a bunch of code, we're going to throw that in a big program, we're going to say, oh, that's great. But turns out it's the current year, and so we're all doing Linux, and so we have to deploy it on Linux. So we're going to break up that one program into a service, and the service is going to have startup and shutdown logic, and it's going to clean its sockets up and all that stuff. It's really great. But it's really cumbersome to deploy. It's a pretty massive thing. So what we end up wanting to do is probably split it up into smaller things. Let's say microservices. This is what AI thinks microservices look like, which is not too far off. You put some JSON in between. You kind of second guess about the JSON as you're going to production, but it's probably fine, probably good enough. But it doesn't feel quite right at the right level of abstraction. So what if we could make the microservices even smaller somehow and maybe give Jeff Bezos more money? You end up reaching for something like Lambda. Maybe it scratches some itch, but then you end up finding that you're deploying way more code to actually manage the life cycle of these little things. And then additionally, you're maintaining all of the state, maybe vendor lock-in. Your operations has now ballooned. It's far from just running a single service. And you start to kind of revisit your foundational myth of like, what are we doing? What are we actually trying to accomplish here? So to give a more concrete example, let's talk about a common pattern that you may have encountered, where a company that I've worked at in the past had, let's say, an API that had some sort of internal routing system where there's messaging going out and there's different exit points for those messages. Maybe you've got like an email service or SMS service or even push notifications or some other target. This is actually not uncommon. You have a bunch of arrows going between these all different services. You might have one database, like a big monolithic database. As your company grows, you end up splitting out a whole bunch of different databases from that, but you might still have the monolith. You have a lot of context that goes along with every request. This stuff gets out of hand. You end up, you take a step back and you realize, wait a minute, we went from 20 developers to now we're at 3,000 developers, right? This is a very common thing for these companies that start small and with best intentions end up creating some sort of monster. But if you squint, you end up realizing that this kind of looks like function calls. Like we're kind of at a functional programming conference. You can kind of pretend that these methods that you're calling, they're even called methods, but we abstract away a lot of that stuff. But what if we could instead just refactor these services so that you have a single, maybe not a single entry point for your entire program, but let's say a single entry point for at least this code path, pulling all the arrows up to the beginning, where you've just got some sort of data trampoline, where you're just bouncing in and out of your services. You have the context going along with those services, or with those calls to those services. Let's say that the payloads that you're passing are sufficiently small that you can actually manage that complexity. You need some sort of data manipulation layer that you can actually transform things so that these services themselves don't have to maintain the structure of all the other services around them. You're trying to make things simpler, right? So you end up, or at least I did, writing something that I hope to share with you all today. So let's walk through a concrete example of what a flow like this would look like for a website that some of us have used, meetup.com. Let's look at what user sign-up might look like. I'm hand-waving a bit just up front. I'm not going to do like email verification or like age verification or anything, so don't put this into production. But it's just an example. But it is running on my laptop, so we'll see that in a second. If we look at what a user sign-up flow might look like, we have a create user function, takes a bunch of parameters, does a bunch of work, gives you back a response. And then we're running on a mobile application maybe, and the mobile application wants to display a bunch of information for the user so that they can derive a bunch of engagement and have a bunch of exciting new users come on and just go forth and use the application. A lot of fun. I have a couple of functions. They're mocked up in Python. They're not actually talking to real databases, but that's okay. They're very simple. The reason that I chose Python is because I want these functions to be so simple that you can reason about them even in a language like Python, right? Like there's a lot of people have feelings about Python, I understand, but you can squint, you can kind of treat it as pseudocode, but you can, if it's small enough, you can still reason about it. The problems with Python come from becoming massive code bases where you can't reason about it anymore. So we're trying to kind of reclaim that from where things typically end up going. So how's the font size in the back? Okay? Okay, good. So this is a very simple create user function. It gets the request body from the request object. You get data. You get 3 fields out of it, username, email, and password. You store it all in an in-memory database like you do in production, and then you return a message saying, hey, the user was created, go team. You also return the user ID, which is very useful. Simultaneously to that, we said that we wanted to look up groups that the user might be interested in, or topics the user might be interested in. So we also have the interests function, where you can search for interests by interest ID. So let's say that the user has sent this data, the interests field in the JSON blob is a list of strings. We are going to look that up in our fancy in-memory database in a different service, and then we're just going to return a list of the group IDs as results. Simple enough that you can reason about it. Now, one of the challenges may be that I want to represent the entire data for the entire flow as a single payload. I'll take a brief digression to talk about a country that exists on this planet called Australia, where we had a website that took 15 seconds to load because the round trip time was so long that it was just limited by the physics. So the fewer requests that you made, the better response time for your users. So there is actually a need for this, even though this is maybe a little bit stretched in this particular example. But this is designed with this in mind. So actually, quick show of hands. How many are familiar with the JQ command line tool? Excellent. OK, good. So let's say that we've got our single payload, username, password. Don't steal my login information, please. And then also interests. With JQ, you could just do this. I'm going to transform my payload into request 1 by accessing the email field, the username field, and the password field. Those are the 3 fields that we accessed from the first service. And then I can do the same thing. I can then look at what the result of running that through JQ would be. And then I can do the same thing with the interest function. I can then just extract that one field from that object. And it would look like this. That's great. But we also want to do this in a sensible way and not just deploy JQ into the cloud. Although, not a bad idea. So let's look at what that might look like using a piece of software that I wrote called the Delegator pattern, or the Delegator, which implements part of the Delegator pattern. I'll talk a little bit more about that towards the end of the slide. So I've created a new virtual host here called Edge. It doesn't really matter what it's called. That's just the name of that configuration block with a method signup. There is a specification called a cryptogram. The idea of just being a datagram plus cryptography. This is still early days for this project, though, so the cryptogram part is still just kind of reified JSON of that thing. But there are plans that I'll, again, talk about closer to the end of the slides here. The first step here is to talk about routing using the pre-flight blob here, routing the username, the email, and the password through to the new user method in the user account service. The response body from that, I can then do something with if I need to. In this case, I don't actually need the response body. I don't actually need the user ID field that gets returned. It is sufficient for me to then make a second request to the interests service in order to get the interests that the user specified. So we can actually see the first pre-flight and the second pre-flight are constructing those method bodies that then go out to those different services. So we hit the first service, we hit the second service. There is space here for a third service, which, let's see why we would need that. It turns out that, remember, our Python function just returns a bunch of group IDs. So even though I submitted this request, I ended up getting group 1 through 6, which is not super useful. But what I can do is I can go back to my service configuration, and I can actually make a third call to the dereference function of interest. So this may actually be solved by a different database, a different service somewhere else that has different access parameters. Maybe you have your search service being served by Elasticsearch somewhere, and then another thing being just the static metadata served really, really fast from some local cache. That's totally possible and very reasonable, but those might have different access characteristics that you need different places to look for that data. So that is possible here. I mentioned earlier that we created a virtual host. This is, let's look at how to actually do that and why. First, actually, let's look at the user account service. So I've described the place to look for this service and the path to that method, as well as the method for that method, the function. So we're thinking of these things as functions, right? So the function call for that thing, I'm going to send a post to /new for that service. I'm then going to be able to use that in any new compositional flow that I would like. And then additionally, the virtual host aspect, I can expose this edge service as any host name that I would like. Here, localhost, just because I'm developing on my laptop. But when we deployed this into production, we actually had a very sizable number of virtual hosts. Closer to the end of this prototype phase, unfortunately, the company is no more. But what we ended up doing was we used this as a tool to migrate some really hairy code paths away from a legacy GraphQL service to a bunch of much more straightforward and simpler to manage Python services with different data backends and different access semantics. This is not theoretical. This is actually, this stuff was in production. So I wouldn't be here trying to sell this to you if it wasn't. I'm actually not selling it to you at all. It's free. Go and use it. The main thing that I think is possibly interesting is that the JQ library is available as a Rust crate, should you be so inclined. The cryptogram component is driven in the Delegator, but the patterns for accessing that are all just basic Rust functions. The idea here was to get us close to a flexible tool that had the kind of access semantics that we wanted to be able to expose this in a way that would allow us to be very flexible. One of the ways that this ended up manifesting was, this has turned into a little bit of story time, but I exposed an endpoint in the Delegator just called evaluate that you could just pass any random cryptogram to, and it would let you, on the fly, describe completely novel accessor patterns for data composition for existing services that you had. If you have those primitives available, you can describe completely novel ways of using your code that you didn't previously anticipate. So now we are going to tease the demo gods with attempting to modify. Let's actually see if I can even switch screens. No? Yes. We're going to actually look at the configuration file that we have been modifying so far. We can actually see that all of these are actually just real. This is real stuff. But what we want to do here is the output of this dereferencing service doesn't meet our needs for the application. I mentioned earlier that we needed the user ID from the user service, and we may need to do some other transformers as well. What we can start with, though, is we can actually just go back up to the output of the sign-up service, this new user function. And I'm just going to add a new, actually, I even have the post flight here. What I can actually do is just down in this post flight on this one, I can say, sorry, I didn't realize that I was going to have to type around a corner. Post flight is just going to be, let's do interests is the, just going to do dot because that's actually something we want. But what we're also going to do is we are going to throw in there the user ID. Typing at an angle is hard. So that is going to come from the in-memory state from our first function here, where we actually set the username. Whoops, it really is hard to type at an angle. So we set the username in a context variable. We also, in the result of this function, we set the user ID into a context variable as well. So we can access those here, and we can just say get the user ID and close the quote. No, close the curly, and then we can close the quote. Does that look like it works? Let's see if it does. If not, Rust will give me a very angry message. There it is. So we're just going to run this. Very angry message. That's very angry. Invalid type map expected a, oh, great. Let's figure out what that is. Oh, good call. Thank you very much for that. So let's run that again. Thank you very much. So we can look at what our new response, our previous response was just this. We're just getting the array. But now we should also be able to see not only that we've transformed it to include interests, but also the user ID. So this as a sort of a network Swiss Army knife edge service with this level of data manipulation and context awareness has been very helpful. So I'm going to go back to the slides here and talk a little bit about the future of this project, and then we'll have some time for questions. The initial design for this came out of a conversation of how to deliver secure end-to-end and durable communication from applications running on the edge on a device or in a single-page application where you're sending potentially secure bits of information into some arbitrary service. It's all well and good to have HTTPS between services, but if you have root on a server, or if you are not even using HTTPS on your internal microservices at your company anyway, this presents a problem for users, especially if you're using or rather exposing your services on the internet and you actually don't have a reliable way to protect your users. Hopefully you're using HTTPS over the internet, but let's say that you're exposing services in a kind of federated environment where other users may be able to publish new services into your ecosystem, or you can call out to other company services, maybe using JWTs, encryption becomes very useful, especially if you are sending the entire context for the payload at the same time, where you may actually derive value from being able to take an entire payload and store that in some sort of durable store, maybe a message queue, and evaluate it later. Because the entire message context, the entire request context is just in a single body that you pass into the evaluation engine, it really gives you a lot of flexibility in that respect for how your application evolves as your company needs evolve. So to start, we looked at the Delegator. The Delegator does a little bit too much today, if I'm honest, but I have the Delegator exposed as two different branches on the repo. The first one is the standalone that we saw here. That's on the master branch. We also have a develop branch, which is the future work for how the ecosystem starts to come together. The ecosystem depends on a registry. The registry is sort of a traditional microservice registry where you have maybe Docker images or some other information of how to deploy a service from code. You have that information that is able to be consumed by the provisioner. The provisioner is something that ideally is something that you understand well enough to be able to manage it. So the goal of the provisioner is to have this group of services, the Delegator, the registry, and the provisioner, deployed close enough that you avoid things like going cross AZ boundaries. The provisioner spins up very small instances of microservices where you're only really servicing requests from one Delegator. So you may scale up to a bunch of those instances, but they get reaped very quickly as those services become unused. They'll just time out because you're tying those instances directly with an instance of the Delegator. You don't have to worry so much about auto-scaling or any of those. It's directly tied to use. So it gives a lot of the benefits that you would typically find from services offered by AWS, for instance. An additional thing is, we talked about this JQ library, the JQ work-alike. It's the data adapter that actually did all of that work, the heavy lifting. That belongs in the sidecar, which is a service that maintains the request state at a single services level. So the service does not need to know about the entirety of the way that this request is being evaluated. In particular, you shouldn't need to have to worry about the cryptographic aspects in a single Python application. You want to just be able to access things from that data blob. And that really kind of gets down to the cryptogram. The cryptogram is in its very early stages currently. Being able to talk about sensibly and predictably encrypting information at point of creation for point of consumption without having to manage a whole bunch of additional infrastructure for that. That is something that I really want to be available for any small startup. The ability to just spin up a service very straightforwardly and start delivering value from that service, prototyping something entirely on your shell using curl, that's a superpower that I want for everyone. So I think the last thing I'll say here is I really appreciate your time, and hopefully you'll join me. Possibly just message me, or if you're on Matrix, there's a Guardrail Matrix channel, and I'm in there. So yeah, thank you very much. Is there time for questions?
One question.
Any questions? Any question? Sure.
Oh, if you could just repeat.
Yeah, sure, I'll repeat it.
The recording's on.
Yeah.
So you mentioned migrating from AWS to
Right, so the question is comparing and contrasting what the first slide showed with the delegators, it's the bouncy one, right? So that against federated GraphQL servers and resolvers. We're working in the same space, yeah, so a great question. The biggest challenge that I have with GraphQL services that I've worked with in the past is that GraphQL is implemented with the best of intentions. And unfortunately, we never quite get to the ideal. So I think a radical shift more towards composition from the outside of microservices is something that drives a lot more value than trying to get everything to play nicely and be perfect. A tremendous amount of work has gone into GraphQL. Don't mean to denigrate any of it. It's a bit above me to be able to trace through it, especially trying to actually write sensible tests. I'd much rather test a single function. So, yeah. Thank you.